All right, in this video, I will quickly go through how to describe rotations in words, graphically, and algebraically. We're going to do rotations in increments of 90 degrees around the origin. Okay, there's two ways that you can rotate, either clockwise or counterclockwise. So if you were to rotate clockwise, that would be the same direction a clock rotates. Counterclockwise is the opposite direction a clock rotates. Now, something to keep in mind, if there is no direction specified, it is always a counterclockwise rotation. So in this example, when they give you a description of the rotation in words, and it asks you to rotate the figure 90 degrees around the origin, counterclockwise is assumed, right? Because it didn't tell us to rotate clockwise, so we assume it is going to be counterclockwise rotation. So one of the easiest ways to do this is to just know the rules, but I'm going to try to draw this visually, okay? As we rotate a point, so if we have point D here, and we want to rotate counterclockwise 90 degrees, we have to take this length of segment and keep it consistent, like it's a radius of a circle. And so we're going to rotate it counterclockwise until we get to 90 degrees. So it's going to make a 90-degree angle here at the origin, and we have to go the same distance away from the origin in that direction. And so that's going to be D prime right there. Call this D prime. I'll label it down there. Okay, and then I'll erase all the auxiliary lines that I used to find the rotation. Okay, then I'm going to do the same thing with C. Okay, I'll actually use a segment here, I think. So if I want to rotate C 90 degrees about the origin, okay, I take this line, and I'm actually going to copy it. Paste it in. So I've got another line here, and I'm going to rotate this line. So I wanted to lock it in, but I'm going to rotate this line just like so. Notice it's going to form a 90-degree angle at the origin, and its length is going to be the same. So essentially I went 1, 2, 3, 4 units right and 3 units up, makes this rectangle, and then I lay this rectangle down, and instead it goes 1, 2, 3 units left, and then 4 units up to create C prime. Again, I'll erase all my auxiliary lines. And I'll move lines out a little. Okay, and then E, doing the same thing. E rotated becomes E prime. Interestingly enough, as I rotated, it maps itself onto D. So E prime shares the same position as D. All right, so then I connect my vertices, because again, I'm not just rotating the vertices, I'm rotating the entire triangle 90 degrees, and I rotated it 90 degrees about the origin, which is counterclockwise. Okay, so if we wanted to rotate it 180 degrees, we'd do that exact same thing, and we would rotate it 180 degrees by doing, taking C prime, D prime, E prime, and rotating it down into the second and third quadrant here. This would be quadrant 1 up here, quadrant 2, quadrant 3, quadrant 4. Okay, but I'm just going to tell you what the rules are for each of these. So the rule for a 90 degrees counterclockwise rotation is X, Y. What you will notice is your X and Y values switch, and then your first one turns into the opposite. So the Y is going to turn into the opposite. That is a 90-degree rotation. That's your algebraic rule for a 90-degree rotation. Okay. Next one is 180 degrees. And the last one is going to be 270 degrees. All right, so again, we get to a 180-degree rotation by doing two 90-degree rotations. All right, so you could just do two 90s. And what that rule is xy goes to, well, I could take these 2 points and flip them the same way. So it'd be back to x negative y, but I have to change the sign of the coordinate my x position again. So if I want to rotate 180 degrees, I have to take xy and transform it to negative x, negative y. Okay. If I want to do a 270-degree rotation, I have to do this one more time, which is turning 3 90-degree rotations counterclockwise. So I could take these coordinates, switch positions, negative y, negative x, but turn the first coordinate, or the new x coordinate, into its opposite. So it's a positive y, negative x. Interestingly enough, just to show you, if I wanted to rotate 360 degrees, if I did that one more time, I would switch x and y. It'd be a negative x comma y, and I would change the sign of my coordinate in the x position. I'd get back to xy. So 4 90-degree rotations gets me back to the original ordered pair xy that I had, which kind of just confirms that our rule does work. All right. One last thing is to just be aware that your 270-degree counterclockwise rotation is the same as 90 degrees clockwise. Okay? So you can get to the same position by rotating 270 degrees counterclockwise or 90 degrees counterclockwise. We can also describe these using negative numbers, so I'm not sure if your teachers went through that. But like, if I said a negative 90 degrees rotation, that would be the same as 270 degrees. 270 degrees. So those two would actually equal each other. All right, hopefully this helps. Good luck on the rest of the slides.